I call to order the 1243rd regular meeting of the Entomological Society of Washington. In spite of the concurrent State of the Union proceedings at the Capitol. First order of business is the reading and later approval of minutes by Secretary Gary.
Nope. Everybody.
Good evening. The 1242nd regular meeting of the Entomological Society of Washington was opened on the 1st of February 2024 by President Don Weber at 7 p.m. in room WG 33 of the National Museum of Natural History. 21 members and 2 guests were present, with 18 virtual members. Recording Secretary Gary Hill read minutes of the January meeting, and these were approved with a few suggested changes from the audio. President Don Weber noted that the executive committee of the society met in late January with the following results. Co-editor Jerry Cook will work with co-editor Martin Hurt to complete the 2023 issues of the proceeding. Lawyers tomorrow have developed a merchandise page for sales of various entomological items such as mugs and t-shirts. The society will receive 10% of the sales funds. For ESW meetings, the current system of monetary contributions for pizza are satisfactory. Curator Talitha Simos requested assistance for dealing with the stories of old proceedings and other items. Contact her for volunteering. Lourdes Chamorro is digitizing 3 early memoirs. Lloyd Shockley noted that there are many old issues of the proceedings in the attic. President-elect Andrew Jansen is evaluating a meeting place for the annual banquet and noted that the Logan Lodge in Beltsville is a possibility. Lourdes Chamorro displayed a new book, Beetles of the World. I'll have to get the author later. David Kirk displayed a paper wasp nest from the Amazon in Brazil. The wasp genus is Charturgus. Program Chair Alan Norbaum was unable to attend the meeting, but past President Matt Buffington introduced the speaker of the evening, Dr. Jeremy Frank, whose topic was the curious troglodytes, insects underground. Dr. Frank has conducted research on the biology of sand wasp of the genus Bembex, which contains some 330 species. These wasps utilize the same sandy areas with several species. They have host-specific habits, utilizing diptera of appropriate size. Adults feed on the gut content of prey, then leave the remainder to their larvae. Several short videos were shown with adults competing for prey and other activities. A few new species of Bembex resulted from Dr. Frank's research. Troglodytes are a fascinating group of insects, and Frank Howarth is a major researcher in this group. He has learned to follow plant roots into caves and has gathered many specimens in 50 years of research. His collections of troglodytes, especially Sticklean padhoppers, number more than 40,000 specimens. Many of the specimens are rare and irreplaceable. Many cave systems are localized and fragile. Islands have many troglodytic species, with many species only known from single islands. The coastal areas have many insects and other animals that are not expected to survive from the rising waters of climate change. Thus, there is currently a strong interest in studying the caves and coast in tropical areas. At the end of the presentation, Manon Davis noted that she and her husband Don co-authored a paper in 2020 in the proceedings, in which 3 new species of Tiniid moths were described from troglodytic habitats in Kenya and South Africa. The meeting was adjourned at 8:20 p.m. Any questions, arguments, threats?
Should make clear that those caves, I don't know if you made clear that those caves were all in Hawaii.
Okay, the homework. Okay, yeah. Anything else?
Okay, the minutes are here for. I wanted to report a couple items from the executive committee meeting that we had earlier today. We're very close to presenting to the membership a revised set of bylaws that, among other things, establish a webmaster as one of our officers, and a few other items. I can't remember. What were the highlights, Matt? That was the highlight.
Largely various components to make it much easier for us to file for nonprofit status, which will then lead to people being able to donate to the society and take tax write-off and be legal.
And we also approved what we're doing right now to be inserted into the bylaws, that is voting by hybrid means, so virtual status. And we also received the report of the audit committee. I have a copy available if you want. Everything's looking pretty good, except the Postal Service didn't count for all the receipts, surprise, surprise. And we also discussed the organization of excess numbers of special publications, hard copies upstairs, which if you want to assist with the inventory of those, I'm sure Felita would be glad to have your help. Reports of officers. Do we have any? Andrew, do you want to say anything about maybe hold that date? Oh, where is he here? Where is he? Well, Andrew Jansen is our president-elect, and he is planning the banquet, as is the duty of the president-elect, for tentatively at least Saturday, June 8th at the Log Lodge, which is on the grounds of the Beltsville Agricultural Research Center East Side. It is a little distance from the Greenbelt Metro, but we would provide volunteer shelters. So, anything else? Go ahead, Elizabeth.
I will stand up. So hi, my name is Elizabeth Young. I'm membership secretary. I have not been attending the meetings for a little bit, but I'm happy to be back. Little personal note, I just started a job with USDA this year at the museum, so I expect to see a little bit more of me now that I have a more regular schedule. Anyway, I just wanted, as membership secretary, I wanted to ask if we have any visitors here today. I know we have one who's sitting right here. Would you like to introduce yourself?
Yeah, sure. My name is Mark Hoffman. I'm an internship here for 2 months till May. Just arrived. Working in Diptera, also Nico, and I just came from Namibia and will be working on rubber flies facility. Awesome. Hoping describing species from them.
That's awesome. Welcome.
Thank you.
Anyone else? Hello.
Hi, I'm Hugh Douglas from CNC in Ottawa, and I'm here visiting the beetle collection and especially the Kresslein with Alex Constantino. And really happy to be here, and thanks for the pizza.
Thanks for coming, Hugh. Anyone else? Hello, Tina.
I'm Anna Wallingford, and I'm currently unemployed, but I'm coming from the University of New Hampshire, and I'll soon be starting a job at ARS. But I will be talking to you about my.
Ooh, awesome. Anyone else in person? No? How about over Zoom?
Hello, hello. Do you see anything in the chat now? Okay.
Thank you all for coming. And oh, hi. I think I can see a hand up for Stephen.
Hi, I'm Stephen Panosian, and like our fellow member, I'm unaffiliated at the moment, but I'm here watching in Zoom land. So the pizza still smells good here. Enjoy.
Fabulous person. Thanks for coming. Go. Okay, well, thank you so much, everybody.
Okay, any unfinished business? Otherwise, we can go to any new business or show and tell. I have a show and tell. I have a show I want to tell about. This is a book that actually is Smithsonian Books. It's entitled Metamorphosis: How Insects Are Changing Our World by Erica McAllister with Adrian Washburn. And it's officially coming out in about a month. And it's very charming set of 10 chapters based on a BBC radio series. And I recommend it highly. I finished it in about a day and a half. I couldn't put it down. So cool little book. I'm sure it finds its way back to me. I'll pass it around. Other show and tell. Didn't someone have Darwin or somebody here? Yeah.
Should I? Okay.
There's just a book laid on table.
Oh, okay. I'm just gonna come over here. What? Okay, I have found this book. I bought this book in 2017, and I forgot about this book in Milwaukee old bookshop. It's called Darwin for Beginners. It's written by Jonathan Miller, and it has every page is a black and white illustration, like hand on ink. So fun. So I will pass it around. They're very funny. I have not read it yet. I found it on my shelf this morning, and I will read it once I get home tonight. I imagine it will also take me a day and a half because it's very quick. Jonathan Miller is not an entomologist. He was a physician, but also he's really well known for his comedic writing, for shows like BBC, ITV, well, no, Channel 4 stuff, British comedy, and also a playwright, and I think largely like an opera conductor. So a man of all, jack of all trades, very cool guy, very passionate about Darwin. So take a look.
Anyone else? Yeah.
Yeah. So I have a book to share with you. This is Steve Marshall's new tome on Hymenoptera. It's a great, it's got like that perfect mix between a coffee table book and like something that's actually good for naturalism. And on the back of it, we have this is the first back of a book I've ever noticed that I have at least know the names or know of everyone on the back, which is wild. But we have a quote from Lawrence Packer that says, "Another marvelous book from the master of insect photography." And he's not kidding. I mean, there's just like so many amazing photos, mostly live plates of parasitoids and stinging wasps and ants and all of Hymenoptera. So if you haven't picked it up yet, I suggest you do. It's, I believe, $95, but when I bought it, it was running on a deal for $50 on Amazon. I don't know if that's still going on. Look at all that paper for $50. I'll start this one over here.
More. Matt.
So it's one of the identifiers for red imported fire ants in the United States. I've often thought it'd be really cool if there was like a test. You could grind a specimen up and put it in some fluid, and it would tell you whether it's red imported fire ant or not. And I kind of thought this was a cool idea, and I shared it with Jonah. He thought it was a cool idea, and we just kind of ran with that. Turns out someone already did it. So this is from ARS Gainesville, which is where the fire ant lab is. And you do need live specimens to go in this, so it doesn't work for ethanol things. So APHIS hasn't officially adopted it yet. But South Korea has, South Africa, Taiwan, which we're sending red imported fire ant to on a regular basis. So I just thought it was I saw it on the wall on a poster. I thought it was a prop. Yes. And I'm like, oh, look at that. And the guy's like, well, yeah, I invented that. I didn't say anything smart out. So I passed this around. It's just a neat, what I did on my last trip to Gainesville. Yeah, go ahead. Don't like disarticulate it and stuff. Like don't lose the parts. It's like a COVID test for.
You didn't bring any live red fire ants.
I didn't bring any live red fire ants. That would be in violation of protocol.
Probably
We all
DC
follow
quarantine.
already. We really wanted to see how it works.
Go to Southern Virginia. They're on their way north.
I think they get introduced to the Eastern Shore on these palms that they put by the tiki bars.
Oh,
Typical. I have one more item. It's not a book, but it was an announcement recently by the ESA Better Common Names Project. Seeks comment from the entomology community on the possible future selection of alternative common names for 9 insect species listed below. And the deadline is March 31st. And prominent among these, in terms of insects we all know, are Japanese beetle, Asian longhorn beetle, Asian longhorn tick, not an insect, Asian citrus psyllid, Asian subterranean termite, Oriental stinkbug, which is Plautia stali, Asiatic rice borer, and African mole cricket. So if you have interest, I have a couple extra copies and you want to either volunteer to see whether they ought to change those names or you have other comments, they are welcome by March 31st. I think that's all we have for show and tell. And I'm gonna let Alan introduce our speaker.
Okay, before that, I could announce our speaker for April is Jader Oliveira. It's from the Faculdade de Saúde Pública, University of São Paulo in Brazil. He's going to talk about true bugs.
Sorry, did you want to say something about layer fasting?
Oh, yes,
Or someone?
yeah. We do. Well, I am not, I think Alan, you are, or Matt, somewhere.
So since the last regular meeting of this society, we lost one of our longstanding members, Dr. Dave Smith, who was 87, I believe, 86 and a half, something like that. Long-standing pillar of hymenoptera research in North America and the world. My own career started looking at specimens collected in his incredibly productive backyard lace trap, which when I finally saw it, I couldn't believe what this backyard lace trap produced. It was a real honor to join him. When I came here, he was already long retired, but a very active member of the hymenoptera unit. Almost all of us who have worked in this museum have handled specimens he has collected. Is collecting, in fact, some of the specimens in the talk tonight might have actually been collected by Dave Smith.
No, they were.
Yeah, okay, so that's just, he's our own kind of Lubo Masner of the United States. And he could be very problematic like any of us. He was also just, he just worked every day and published something like 407 papers, 150 of which were after he retired. So he just got going after he retired. So he's our honorary president. Yeah, just keep him in memory if you want to know more about him. Tom Henry and I wrote an intro to Festschrift for him. It was very touching to give him a Festschrift while he was still with us. That was actually the only time I ever saw him actually surprised me. Like, he didn't know what we were organizing for him. So Jonah Ulmer, who's here, has helped a lot the last year or so since Dave lost his wife. And if you want to say anything or
Sure, yeah. I mean, I worked around and under Dave pretty closely since I started here with USDA. I mean, I remember when I came to interview with Buffington and Mike Gates and Matt, I wanted to work on sawflies, and Matt like, oh, you should talk to Dave Smith. And I, at the time, didn't even realize Dave Smith was still alive. And I went to his office
and Matt introduced me, and we started working together pretty closely. And last summer, Dave's health took sort of a turn. He stopped coming in, and so I would almost weekly go to his house, and we would sort insects together and work on sawflies. And he was very giving with his knowledge, and sort of his expertise. Will be deeply missed. I mean, I've been fielding so many emails from around the world of people, wanting to send condolences. And yeah, it's, I mean, I can't think of anyone else within, some fighters certainly, but he was one of the few sort of masters of at least the 20th century. And it would be a deep loss now that he's gone. Yeah, so I mean, I'm still in the process of cleaning out his house. Just the research he had there and the specimens that he didn't even get to. I mean, he had such a prolific career, and he had, right up until he was in the assisted living home, he was still working on these malaise trap samples that so much of us work off of. I think many of us in USDA saw the email. He took his microscope with him when he moved to the assisted living home. He was sorting and IDing stuff right to the end. So he will be deeply missed. Certainly by me, but I think by everyone. So yeah.
I would just say, despite all that he accomplished, he was a very quiet, unassuming kind of person. He didn't like to travel, apparently, which maybe that was his secret. He just stayed and kept his nose to the grindstone and just kept churning things out. Every once in a while, I collect the sawfly kind of by accident and pass it on. He was just so delighted, to get and collect them.
Yeah,
he was just so pleased to ever see him.
I mean, I would see him so often. He's a very private, very. I'd go to his house and I'd be there for an hour or two, and it was mostly me talking, and he would just kind of sit there and nod. And then I would drive home, and an hour or two later, I'd get an email from him that was like 2 pages long of him responding to everything I said in the last hour or two I was at his house that he was just kind of nodding to. So he was always more talkative over email than he was in person. But yeah, he was always excited for any sawfly. I brought him some Carida over Nepenzia, which is really rare genus of Enfirdinid. And I've never seen him giddier, and always very neutral. And I was like, oh, I found a Carida. And I mean, it was like, a child at Christmas. Like, wow, we only have like 4 of these in the collection. This is the most amazing thing I'd seen. Come, look at it. So, yeah, devoted heavily to his work. Anyway.
We also lost Ralph Eckerlin. I hope some of you knew him. He used to come to our meetings frequently. And Ray Gagne has cut out an obituary from the Washington Post, and I'm going to read the cogent highlights. It is with profound sadness that we announce the death of Ralph Peter Eckerlin, PhD of Annandale, Virginia, on February the 9th, 2024. He was born in 1938 in New York. He obtained a BA in Biological Sciences from Rutgers in 1960, an MS in Zoology from the University of Miami in 1962, and a PhD in Parasitology and Zoology from the University of Connecticut in 1975. He joined in 1971 the faculty at Northern Virginia CC, where he taught multiple science classes for 41 years. In in addition to being a gifted teacher, Ralph was a prolific researcher and writer, collecting and describing at least 6 new species in several countries. He authored over 70 peer-reviewed publications, a biology lab manual, multiple book chapters, and edited a volume on Appalachian biogeography for the Virginia Museum of Natural History. He was a world-renowned flea specialist and co-author of an exhaustive compendium, The Synapomorpha of North America, soon to be published in the Annals of the Carnegie Museum of Natural History. I guess that's good enough, but I hope some of you remember him. I certainly thought of him as one of the more friendly people, quiet, like Dave Smith, but very effective worker. It's so sad to know about people in detail after they pass. Okay.
Okay, Gary, we have 20 Zoom participants
Okay,
tonight.
thank you.
Where's that? Okay, so it's my pleasure to introduce Kresslein. He didn't want a big introduction, so I'll just say that he has a bachelor's degree in biology from Kenyon College. And he migrated to California, University of California, Riverside, where he worked with Jim Harity. And he is now a USDA ARS postdoc at Systematic Entomology Lab.
Right. Okay. Minimize the whole thing. Hold on. Here.
Like more, it's like I for the mean controls.
Perfect. Thank you.
All right.
Hi, everyone. It's exciting to get to talk at ESW. I remember when I was an intern at Smithsonian back in 2015, my first ever kind of group entomology activity was an ESW meeting where May Beerenbaum taught some of the annual banquets, and so it's kind of fun to come back and get a chance to talk at one of these. So usually when I get up here and talk, I talk about tiny wasps and how they're related to one another, and I'm going to do something just like next door to that. I'm going to talk about tiny wasps and parts that they're made of. Or I'm not, it doesn't forward. There we go. It's going to do like 3 in a row now. Okay, so we're kind of living in a golden era of phylogenetics, phylogenomics right now for Hymenoptera, where people across the planet are doing incredible work at all levels of the hierarchy of the Linnaean classification. So we have papers at the ordinal level, like Blamers, big Hymenoptera phylogeny, with huge numbers of taxa, looking at diversification and key innovations. We have Astrid Kroad's paper on Chalcidoidea at the superfamily level, again looking at divergence by geography and updated classification. At the family level, we have papers like the Harity et al. 2021 phylogeny of Eucaridids, looking at the cool ant parasitoids and their hypermetamorphic larvae and how those patterns are resolved. Subfamilial level, looking CASO 2022, looking at Braconid subfamilies and their relationships and the reconstruction of life histories there. And then even at the generic level, we have people like Jill Oberski doing work with Dory Myrmex, looking at the relationships of those species and dating analyses by biographical analysis. So right now really is the best time, I think, that it's ever been to be doing work in Hymenoptera. And it's the time to be asking interesting questions about their biology. We have the trees, let's ask about some patterns. And that's where this story starts. So like Alan mentioned, I work at UCR with John Harity. And this story starts UCR adjacent, actually in 2017 during my recruitment. And John had taken me out to Whitewater Canyon to go collecting. And we were driving in his Toyota Prius, and I had known him for all of a day. And he looks at me and you shouldn't have done that because we were driving. But he goes, so there's these rods. And being young, dumb, and inexperienced, I went, what? And that's kind of as much intro as I got at that point. He was like, yeah, they're in wasp teeth. I'm like, so just like you, I was confused, but unlike me, you're gonna get an introduction. So, Hymenoptera. There are a lot of long-standing clades within Hymenoptera that many studies have supported. I'm gonna highlight a couple of these. We have Symphyta, which is a known paraphyletic grade. We don't have the wasp waste, mostly phytophagous things. And then we have Apocrita, which is all the wasp wasted stuff. Parasitic ancestor, all of the Aculeata are up there, all the parasitoids. And then kind of other clades that are really well supported through many studies. We have Unicaparita, which is our upper Symphyta plus Apocrita. And then we have Vespina, Arusidi plus Apocrita. So the kind of base of the tree has been supported through many studies. I want to talk about some of the infraorders within Apocrita. So a lot of the foundational work to establish these infraorders or what he called infraorders, was done by Alex Resnitsyn, a paleoentomologist from Russia. And in his kind of opus piece in 1988, he outlined 4 major clades within Apocrita. The Ichneumomorpha, which is present-day Ichneumanoidea, Vespomorpha, which is present-day Aculeata, and then 2 additional clades, Evaniomorpha, which is made up of a number of parasitic groups, Seraphronids, Evaniids, stuff like that. And then last one is our Proctotrupomorpha, which has all of the rest of the parasitoids. In fact, we have 6 superfamilies in this group. Cynopodia, our gall wasps, Platygastroidea, Proctotrupoidea, Diploidea, the really tiny superfamily, Mimeromatoidea, and then the gargantuan one that I work in, Chalcidoidea. So this is the phylogeny from Resnitz in 1988, and it is, I think, cryptic to say the least. I remember picking this paper up during grad school for the first time and looking at it and thinking to myself, I don't know where to start. But here's the figure where he establishes Proctotrupomorpha, and you can see all of those groups that I mentioned therein. So one of the challenging things about figuring out Proctotrupomorpha is figuring out how he's defined it. And there is no place in this paper where he goes, the synapomorphic characters of Proctotrupomorpha are : instead, we have this paragraph that starts 4933, Mesosurfidity. And Mesosurfidity is the fossil wasp family that we're looking at here. And I'm not a paleoentomologist, but I can't see a ton of characters on these. But Alex Resnitsyn came up with there we go. Came up with 8 characters. Looking at these, 7 of them I don't find particularly effective. So the first one is this propectus extending behind and above the first spiracle. The propectus is a kind of ventrolateral structure of chalcidoids. As far as I know, it's in chalcidoids. Maybe there's a syntactical choice that was made here that I'm not familiar with, but as far as I know, this is chalcidoids only. The following 4 characters are all based on absence, and absence characters are never particularly useful for diagnostics. They're not great synapomorphies either. We then have this male genitalic character, which is reduced in a number of chalcidoids and other Proctotrupomorph taxa. And then at the bottom, we have this very ambiguously applied larva temporarily endoparasitic or facultatively fully ectoparasitic, which is not a, non-morphological characters don't make great synapomorphies either. So we're down to 1 character that kind of reads like a synapomorphy that you might be familiar with. head with lower tentorial bridge intervening between postgena to reach occipital foramen and to replace postgenal bridge. So essentially it's suggesting that the postgenal bridge shouldn't be there. In the image that I have up on the TV right here, I have on the left two posterior faces of platygastroid heads, and then on the right, that's a chalcidoid back of the head. And PGB stands for postgenal bridge. So we have between postgena, or to replace postgenal bridge, we have the lower tentorial bridge is there. And I wasn't sure what to make of this, and so I went to Matt and I said, "What do you make of this?" He said, "I don't know, ask Gary." And then we asked Gary, and he said, "For the love of God, don't ask me questions about the back of the head." And so it kind of stopped there. We were like, all right, if Gary doesn't know what's going on here, I'm not gonna like break my neck trying to figure out what postgenal bridge is. It's an ambiguously applied character. So we have no great synapomorphies for Proctotrupomorpha. And yet, Alex made some sort of deal with a greater power or a genie, I don't know, and pulled out a clade that has been supported in every single molecular analysis since 2011. And really well supported as we continue to add taxa and continue to add loci. As we make the data set bigger, it only gets stronger. So how do we define this group then? Well, let's get to our title character here, our mandibular rods. So these internal structures were first illustrated in 1919 by this guy Hasse in his species description of Lariophagus I can't do this species epithet. Anyone want to take a shot? Distinguidus. Some consensus across that. And you can see that there are these kind of elongate structures originating at the apex of the mandible and then blunting somewhere in the middle of the mandible. And for the next 100 or so years, we've had various papers illustrate them and never particularly focus on them. So we have different chalcidoid groups having their mandibles illustrated with these mandibular rods: pteromalids, aphelinids, certids, urtomids. And so we think, okay, maybe this is a nice synapomorphic character for Chalcidoidea. Cool, those exist already. But then in 1989, Ronquist and Nordlander put out this nice morphological study on Babalia rufipes. And in the figures of that, you can see this nice internal face of the mandible and 3 rods sticking out of the mandibular foramen. And they talk about it briefly. I think it's a single paragraph, and they say that the skeletal structures are present in some subset of parasitoid wasps, that they're skeletal in nature, and that some scientists have suggested that they may be associated with some sort of glandular system, some sort of, goo excretion system. But all of a sudden, we have rods in 2 superfamilies. We have chalcidoids and cyanopoids, and there's a lot of taxa in between chalcidoids and cyanopoids. So you think to yourself, all right, maybe it's time to start looking at this character with some seriousness. So the objectives of this study were to determine the distribution of this character, get a sense of their phylogenetic signal, and make some postulations on the putative structure, or the structure and putative function of it. Off we go. So me and my collaborators, and there are a lot of collaborators on this paper, I'll acknowledge them all at the end, gathered 109 taxa representing 93 hymenopteran families. And we went through and did our best to visualize the specimens. Now, this project visualization-wise didn't start collaboratively. I was working on this project since the beginning of graduate school, and basically I was doing slide mounting. So you take a wasp head, you knock the head off, you throw it into KOH, or you do DNA extraction, and the proteinase K will clear it. And then you mount it on a glass slide in Canada balsam. And you get something that kind of looks like this image on the top right, where you have a translucent mandible with the mandible rods fairly reasonably visualized. At the same time, or yeah, probably at the same time, Brendan Boudinot and Thomas van de Kamp are working on synchrotron synchrotron-based microtomography. So basically, a synchrotron is a particle accelerator. You get particles moving really fast, and then you have to vent them somewhere once they're done accelerating. And so you vent them onto the wasp. And the particle will hit the wasp, the energy scatters, and that can be translated into CT slices, much like if you're at the doctor and you do a CT scan, they look identical, except it's a wasp instead of a. So Brendan and Thomas are doing these big studies with the goal of really understanding the ground plan of Hymenoptera, and somewhat incidentally the Hymenoptera that they are studying have heads and mandibles. So when Brendan was here all last year, and I got here last August, I ended up talking to him about these rods, and he was showing me his CT data, and I go, hey, you got any rods in those CT data? And he pulls them up, and immediately they're super visible. They glow really brightly on the CT scans. And so we started this collaboration. And in addition to that, we've done a little bit of select imaging using SEM and confocal in order to look at very specific cases that I'll talk about later in the talk. So there's a lot of imaging for this. All right, so here's our distribution. Rods were identified in all families within Cynopoidea, Enfidigastroidea, and Chalcidoidea. And then in select families within the Diaprioidea. So you can see the sister clade to Diapriidae is these two families, Mamingidae and Monomachidae, which are kind of really rare oddballs. Anyone who has the Hymenoptera book, there's some live pictures of Mamingidae in there. And so, yeah, they're really, really well distributed across Proctotrupomorpha. However, they are not everywhere. Rods are absent from Proctotrupoidea, Diapriidae sensu strictu, and Mymeromatoidea, as well as always the outgroups. We never found them in any of our outgroup sampling. They do not exist. Some of the things that do exist are these. So sometimes you'll find an empty mandible, like in this trigonalid, there's just nothing in there. And then other times you'll find, like in this Arucid over here, a hollow mandible with this kind of diffuse network of soft tissue. Another common feature is this single spur. So if you look into the scaliated mandible, you can see that there's kind of this, but this is very different than the rods. The rods are almost freestanding within the mandible. This is kind of fused to the mandibular, the walls of the inside of the mandible. Then we have two very strange cases. This is a Sapigid, where we found something that's kind of almost analogous to the rods. You have a process originating in each mandibular tooth, but rather than maintaining their individuality, they merge towards the middle of the mandible and then exit the mandibular foramen. And then we have this really weird structure in Stephanids. It's a very thick, elongate structure that's kind of like lobate. And if you look at the cross section of the micro CT, there's a very discrete tube that runs through the middle of that. So it's, I think, probably the closest to the mandibular rods, but it's still structurally quite different. So we didn't include it among the mandibular rotted taxa. So we end up with kind of two schema here. We have either a gain at the base of Proctotrupomorpha, and then subsequent losses across Proctotrupoidea, Diapriidae, and Mymeromatoidea, or we have this convergent scheme where there are independent gains in the common ancestor of Cynopoidea and Hymenopteran, in Monomachidae and Mamingidae, and then in Chalcidoidea. So in order to kind of explore this, we did ancestral state reconstruction with these codes our blue is mandibular rod absence. The kind of cream color that shows up really, really poorly on the screen is present. And then we coded the other characters that we were seeing in non-Proctotrupomorphs as well, and they're up here. It's not really important for this talk, but they're there. The spurs are kind of well articulated through some of these lids. And so what we find with our ancestral state reconstruction is that the most likely recovered schema is that we have independent origin of rods in Platygastroidea plus Cyanopodia, and then also in a second introduction in Chalcidoidea. And then there is this really unlikely case right here where the common ancestor of Diaprioidea and Chalcidoidea has rods, but it seems that like that ancestor is rod absent, and the most recent common ancestor of Proctotrupomorpha is also absent of rods. I don't like this. It does not spark joy. And so I think there are a couple things that I would like to explore in the future that might help resolve this. Primarily, we're mapping all of this data onto the Blamer et al. Phylogeny because it's the most well-sampled hymenopteran phylogeny out there. However, it's missing Mamingidi, and it places Ismarini, this subfamily of Diapriidae, in I don't want to say controversial place, that seems too strong, but a contested place. Oftentimes this is recovered as the sister group to the rest of the Diapriids. In this case, Amboscitrines are recovered as the rest of the Diapriids, and Ismarini splits Diapriini in half. And so if we had Mamingidi in this tree and we had Ismarini where we traditionally have expected it, we'd have 3 taxa with rods at the base of Diaprioidea, and I imagine that would probably affect the ancestral state reconstruction. Additionally, there's been a lot of extinction in this group. I mean, we have groups like Chalcidoidea where they tried to radiate outward and then were shunted back into Australia and then radiated outward again. So we know that there's taxa that were lost there. We have at least 6 fossil families of Proctotrupomorpha that, you know, if they're at all as diverse as extant Proctotrupomorpha, we know we're missing taxa. So with that absence, it becomes very challenging to try to reconstruct the states of the backbone on this tree. And then you can go with the John Harry approach. Molecular data is a lie. The tree's upside down, which he doesn't really believe molecular data is a lie, but he'll gladly tell you. And essentially what he's suggesting is that the molecular data has got something wrong, and that Proctotrupomorpha should be at the base of the tree because it matches his idea of a ground plan Proctotrupomorph. I think that we have enough trees suggesting that that's not true that we can kind of put that to bed. So, hold on. Anyone else need to get in here? So we're left with kind of an imperfect synapomorphy. It's present in the majority of taxa, never in the outgroup. It's easily recognizable. It's not unambiguous. You don't look at the mandibular rods and go, is it not? And then on the other hand, it's ambiguously absent from a lot of taxa, and we're not exactly certain why, and we have an unclear ancestral state. So it doesn't really work, but it's not in the outgroups at the very least. If you see something with rods, it's a Proctotrupomorpha. Okay, so now we're left with what is their putative putative structure and function. Is the next thing we're moving to. In conclusion, we have rods present in 4 of 6 superfamilies and perfect synapomorphic Proctotrupomorpha. So what's going on with these rods? What are they? What do they do? So mandibular rod structure, we're going to start off with the rod formula, meaning the number of rods within each mandible. It's variable between taxa. The most common states are 3-2 or 2-2. 3-2's present in chalcidoids and cyanopoids, and then 2-2 is present in all sample taxa. It's actually by far and away the most common state. And then we have some rarer states. We have 1-1 in Diarinus, which this is a challenging picture to parse because these mandibles are really weird. but you can see the rod coming up from the tooth right here. It goes all the way up almost to there. And then we have this weird guy, this is gastroencystris, and there's actually a very short rod in each of the mandibular teeth, so we ended up with a 4-4 state there. And this is kind of why we decided not to do ancestral state reconstruction with rod formula. Having sampled broadly across the family, but not particularly deeply with any family, it seems like there's a chance that we run into weirdos anywhere. So additional taxa need to be sampled to really resolve this question. So mandibular rods also seem to be associated with real teeth, and real teeth is in quotes because I don't really exactly know how I want to talk about this yet, but this is what I came upon for today. And let me kind of walk you through my thought process here. So each rod originates from a single tooth in the mandible. So if we look at the Abalia mandibles up at the top, you see 3 rods, you can see 3 teeth. Over here you see 2 rods, this is broken in half, 2 teeth. Same here with the Ormyrid, 2 rods, 2 teeth on both sides. But the morphology of what a tooth is in this sense is kind of variable. So if we look at the monomachid mandible, we can see that this tooth is kind of just a big truncation across the mandible. Or if we look at the Ormyrid mandible, you can see we have kind of an apex, and then it goes off to the side and forms another truncation. And then particularly interesting is this pteromalid. There's the DJ. Mandible, where we have what is apparently 4 teeth, but only 3 rods. And if we look at the slide-mounted tooth, you can see that most inner rod arises from between the innermost 2 teeth. So we seem to be having some sort of modification of teeth here. Another thing that's interesting is that not all apices are real teeth. So in this paper from 2021, Thomas van de Kamp did some microtomography and showed us this really wild-looking colotrechnine with essentially antlers that are shunted out of the front of the mandible like this. And so we downloaded that data and looked at it, and I was really hoping we were going to see something really weird, like rods going off into the distance. Unfortunately, they're skeletally hollow. There's nothing there to be seen. So we can have things that look like teeth that don't have rods. And so what I'm proposing is perhaps the loss of the rods may be associated with the reduction in teeth. In a lot of these groups that have no rods, we have kind of really derived odd teeth. We have this bellatine, which isn't that weird, but it's quite paddle-like and small. We have this embossitrine where we basically just kind of got this like little fork at the end. Again, it's very paddle-like. And then in this Van Horneid, we have kind of like, it almost looks like gears, and they're facing the wrong way in Van Horneid so that they open exodontly. So there may be some sort of association between lack of real teeth and the absence of mandibular rods. Some other putative function stuff. A lot of early scientists proposed that these rods might be glandular in nature. And in fact, in this top illustration, you can see that the researcher has drawn a mandible gland kind of tightly associated with the mandibular rod. And I think Istvan has a paper coming out that shows something similar with much more advanced imagery. But I think there are some issues with this. Even though the rods are hollow, we used micro CT. We took the top off, and you can see that there's actually a hollow tube in the middle of there. But if you look at the way that the rod arises from the integument, it kind of comes up and inward from the integument itself. It's not like the bottom illustration where the researcher has drawn the rods penetrating through the tip of the mandible and kind of having a channel out towards the external world. So then what maybe is it? And this is where I start my conspiracy theories for the night. We think that it may be a chordotonal organ. Quarter-tonal organs are kind of a common mechanosensory apparatus in insects, where you have kind of this a muscular organ closely associated with the nerve, and they can be used for a lot of things. In some cockroaches and flies, they've studied them reacting to air moving past them, and that makes CD move, and that triggers quarter-tonal organs. So Brendan and I made this 3D scan of, this is a Thyneid head, and I know what you're thinking, Thynids aren't Proctotrupomorphs, and you'd be right. However, all of the scans with the Proctotrupomorphs, the heads are too small to really see this. It doesn't render very well, but you can see on the scans themselves the structures that I'm illustrating here. So you'll have to imagine with me that we're looking at a slightly smaller wasp. But even in the Proctotrupomorphs, we see a nerve come out of the head, our mandibular nerve come out and kind of go to the lateral side of the head here. And then this oral muscle, OMD5, kind of comes and wraps in and around the mandibular nerve, and then heads down into the mandible itself. Now, in Proctotrupomorphs, what happens is that instead of going down to, this continues kind of behind this purple thing all the way down and connects inwards. What happens in Proctotrupomorphs is that the muscle kind of splits apart near the blunted end of the mandibular rod and diffuses around. So it's very hard to trace past a certain point. And so what we're thinking is happening is maybe that muscle is coming in and around the rod itself and interfaces with it as the mandible is used. The mandibular rods themselves are actually quite flexible. I've cracked the back half of a mandible off before, and they're very bendy. They will kind of bend over, and if you push hard enough, they snap pretty easily. They're not super, super rigid. And so maybe what's happening here is that these rods are propagating signal as the mandibles are being used up to this quarter-tonal organ, and that's being translated by the brain into sensory stimulus. And so this last slide is just kind of for fun. It's a conversation that Brendan and I had maybe a week or two ago, where we were coming up with ideas of what this means. So this is Brendan, if you don't know him, and this is the margarita that we were having back in October, when we were talking about, oh, it would be really nice if we could have a really fresh specimen of Proctotrupidae so we could see what's going on in the mandible when there aren't rods. And right as he said that, 2 Proctotrupids fell into his margarita. So here is the CSLM scan of Margheim. And thank you. So here's our mandible right here. And you can see that, that inside this mandible, there are no rods, but there's this kind of nougaty center that we're calling mandibular pith. It's this diffuse network of soft tissue. And it looks very different from our very clearly striated mandibular musculature. So we were just like, what is this maybe? And kind of our very preemptive working theory is that maybe what's happening is that the rod sits within this mandibular pith, and as the wasp is masticating, as it's trying to emerge from a host perhaps, the vibrations from that chewing go up the mandibular rod and are picked up by that pith and then translated by OMD5 up to the quarter-tonal organ, kind of like the beluga melon. It's a fatty matrix that transduces signals. And so maybe what's happening here is that there's an advantage, a competitive advantage to being able to get out of your host with the least amount of energy. And if you have an organ that can determine a soft or vulnerable spot within the host to get out, you can save yourself energy and then be more successful. Now, this is all really, really speculative. And as I'm talking to you, I'm starting to feel kind of like a little crazy. Like I'm the person that's saying, so there are these rods. And so I'd like to acknowledge a bunch of people here. I have a bunch of co-authors who've helped me in this. Brendan and Jonah kind of are the originators of a lot of this project. A lot of early conversations with Jonah and a lot of more recent conversations with Brendan have kind of landed us at this point. Andrew Jansen is I think he's probably a wizard because he's so talented at imaging. Thomas is, been a great help with synchrotron. John Harity is the reason that I'm standing here. And then Mike is also the reason that I'm standing here. Everyone's been great. I have a lot of people that have counseled on this project over the course of years. These are the names that I could think of immediately. I'm deeply terrified that I've forgotten somebody. And if I have, I apologize. And then I wanted to acknowledge Dave Smith as well. Like Matt said, a lot of the original specimens that went into the survey for this came from Dave's malaise trap when I was a first year in graduate school. And it was a lot of the weird stuff too. A lot of the Proctotrupomorpha, Pelicinus, Benhornia stuff you just don't see. So a lot of the reason that this was possible is because Dave kept this project up for so long. And I'm very thankful for that. And then I had one last special thanks to the Mission DuPont Circle restaurant for the delicious lunch. And I'll take any questions that you have. Thanks so much.
Yeah, go for it. So do Proctotrupomorphs do something different with their mandibles and their parasitic?
I mean, I don't believe so. A lot of them are, I still think, using their mandibles to escape hosts and get out. I think that, but there is a difference in the shape of their mandible. So there very well might be. I'm squarely in calcidoid land most of the time, so I'm not certain. That's a good question. Hey, Paul.
Hey, nice talk.
Thank you.
Curious, the ASR, how many origins did it return for the rods? Refresh me. I'm just curious if it differed from a straight up optimization.
We had, I don't think it did, no. It picked the one with less steps.
But fewer steps, that's okay. I had to get you. But like 2, is that what we're talking about, or 3?
So there's a gain and 3 losses or 3 gains.
Got it.
Yeah, Matt.
Amongst the Calcidoidea, how common is a falcate mandible sort of state?
Not particularly common. I mean, you have the Eucharitid and the Kresslein.
Have those been sampled?
Yes, they have.
And they have rods?
Yes. There is no lineage in Calcidoidea that we have sampled. All of the old families have been sampled. A major chunk of the new families have been sampled. There are no families missing rods. Agionids have them.
Just
Protowinids have them.
Okay.
Oh, hey. I should add that.
Does anybody else know of any other families that have?
Yeah, I'll put out a box.
Yeah, you should.
I mean, I've had long-standing discussions with Lubo about mandibles that operate kind of an abnormal plane.
Yeah.
I think we talked about.
Yeah, we did the kind of posteriorly oriented things in the Tricopria.
There's the kind of typical diapriid state, which is itself within hymenopteran period.
Yeah.
But then there's a bunch of like Tyrannocelia, really bizarre silly on it.
Yep.
That teeth move in basically a vertical plane.
I
There's
wanted
sign
that.
of boys like that. I'd be really interested to see, because we hypothesize they are using their mandibles in a fundamentally different way than, because their muscles are different, their head shape is different, everything associated with their mandibles is different. We really need to see if the rods we expect to be there are there, and if they are, if they're weird, or if they're missing, like the antler.
Yeah. Well, so the antler wasp does have rods in this part.
Oh, not in the
this part. And that's why I think that's interesting, is because you clearly can have apical structures, very pointy tooth-like structures without rods.
Right.
But then you can have very weird non-tooth-like structures with rods sometimes. Like it gets funky, like in Agionidae, like in Dirhinus, where it's just like a tooth. So I mean, it's not. I think that it's likely like a developmental thing. And I didn't put the slides up for here for this. I have a whole bunch of developmental series of Mycenopharax and Sphalangia that I got from a vivarium in California, and they sent me like 5,000 parasitized pupa, and I dissected a whole bunch out, and you can see from the first like squishiest, whitest, most unbaked pupa all the way to almost adult, the development of this rod. And it starts as the mandible sclerotizes from the tip basally, and you can see the rod kind of go up into the head as it goes. So there's definitely some sort of like developmental thing there. Is there a question over here? Before I go down? Go down. Amy, out.
So is like the shape of the mandible, like the number of teeth and so on, shape a useful character within these groups? And with looking at the rods, you can figure out how this is.
I think potentially. I think there's a lot of work to be done to determine if my wild statement about toothness is true. Dentition, thanks. But a lot of the new pteromalid families use number of teeth as diagnostic characters. A lot of like subfamilies, I think Calcedonia will do that, where you have like different shapes of the aphid mandible to tell you about the identity of some of those groups. So yeah, there are useful informative characters concerning the number of teeth, and perhaps knowing that the rods could provide information about that. Yeah.
Need to be the bearer of bad news.
Do you want to be the bearer of bad news in public?
There's variation on the species level, number of rods.
Don't say that. That is exciting bad news, though. I do like that.
Like the dental count. I mean, because remember back in 2019, we were like trying to work out if there's some algorithm for rods versus dentition, like dental count.
Yeah.
And then Ishvan has some student who's working on this, and they emailed me and they're like, yeah, I'm working on this like Nasonia group on Oneida and like different species, but within a species I'll get like 3 and 2 or 3 and 3 or 2 and 1, or sometimes a 3 and 2 will swap sides.
That's pretty cool. I'd like to see that. I mean, I haven't seen the data, but I mean, if that's either we have some sort of like species thing going on there, or yeah, and John, none of this is real. No, but like that could be really interesting if it's a much more flexible character, especially because you tend to see the rods coming from the teeth. And if is the number of teeth changing, or is it just the number of rods?
Well, there was also, remember, there was something I want to ask, that there were states where you would get was it from a given tooth, you would get basically a rod extends and then it kind of splits.
The rod splits itself?
I feel like either the rod splits or.
So we have this guy in pteromality where the rod emerges from between teeth.
Yeah. This is what I was thinking of. Yeah. So what do you make of that?
So what I was suggesting was that we have rods associated with teeth, and so this is like some sort of garbled denticles that are associated with a single tooth. It's a truncation with an invagination.
Do you think these are like cuticular derived? Or
The rods themselves?
Yes.
I think probably.
I mean, but there's no invagination. Like if it's derived from the cuticle, right? It's a single layer of epithelial. You can't just generate an invagination without some point of invagination.
I know you're right. This occurs to me as well, but I don't know what to make of it. I mean, I've looked for a pore within a bunch of the scans, there's no pore, there's no hole, it isn't an actual invagination. And so it appears to be rising from a bed of nothingness, which makes no sense. And so
Are you of the thought that it's glandular? Is that? Like,
I am currently not of the thought that it is glandular, because where would the goo go, Jonah?
I mean, if they're class 1 gland cells, they can osmotically pass through.
Oh, you're thinking like an internal, like it's not like an enzymatic. A lot of every time I have this conversation about glands, it's about like enzymatic digestive blah 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 something. You're suggesting that it's secreting internally, and that's
Could be.
a good idea. That's much
You
fun.
also have intramandibular glands.
See, that's my beluga, Jonah. It's not as much fun. But no, it's like that's a really solid thing to explore. From the and one of the things that I want to do as soon as it gets warm and I can go collect new stuff is take a bunch of Proctotrupomorphs and chuck them into CLSM and see what's in there. And is it hollow? Is it full of fluid? Is it, who knows? But good theory. Yeah.
So the ones with rods, are they hollow except the rod? Or what other substances in there?
Yeah, that's exactly what I was saying. Is that we want to get the
Right, you don't know that.
We like just got this, and so I was like, oh, that's kind of neat. Really, all I wanted to see was, is there anything in a mandible that doesn't have rods? And then I went, oh, I really hope that's in lots of things. That'll be interesting.
Speaker, as someone who doesn't know anything about hymenopteran systematics, how arcane the topic is mandibular rods? Like, what proportion of scientists working on hymenopteran systematics know about?
No one outside of like parasitoid land is going to talk about them, but I do feel like in parasitoid land it's kind of like this like topic that like comes up and people are like, yeah, those are weird. I don't know what's up with it. It's not like a super widespread thing.
Pretty arcane.
Pretty arcane.
Just arcane enough.
The White Tower.
Going off of that question, so you were in that Prius, and
I was in the Prius.
you were in that Prius, and he just said rods, and there was like no other. You had never heard this at all applied to hymenoptera, like are coats and rods in your eyes. Like, was this the first time you'd ever heard of this without any context at all?
Yeah.
It's a good story.
No, I mean, and for those of us who have had the great pleasure of working with John, this is not an uncommon confirmation of conversations. You'll be sitting, there'll be a kind of silence, and then there'll be a really long so. And
No, separate.
yeah, she's like, but yeah, no, I hadn't heard about this. I was pretty new to Hymenoptera still though.
Just the mystery alone of the single word rods, what just brought you down to that.
Well, I mean, it was just exciting because at that point I didn't know very much, and it was exciting to be like, oh, there's like organs that people don't know about. What? And so I have followed up with it every couple of years for a long time.
That's awesome.
Now we're here.
To follow up on that, there's almost as much morphological diversity within Calcitonia as there is for the entire order of Hymenoptera.
Oh my gosh.
And there are so many folkloric characters and states that are just like known bizarre things that we just talk about. And so I heard about these from John, I think after a lot of beer from them. And it was just another slew of weird things that Hymenoptera have. And we just kind of talk about them. Yeah, they are arcane. This is the first like actual analysis of it.
Yeah.
What's the difference between the subpyramidal bridge and the postganal bridge?
Don't ask me questions.
Why can't we ask you?
Roger's not here.
That's scary. I don't know. Like this is as far as I've got on that thought, and the answer is it's really worth exploring this. But I don't know. Yeah.
Genuinely, it was like 2024, like the next.
It was like a week ago.
It was earlier this week.
Yeah.
It was like
Yeah.
Monday.
I knew you were gonna have this talk, so you just kind of nice
Gary.
little quote.
Yeah.
That's cool.
Well, because I was working on writing up the manuscript, and I'm like, okay, why are we doing this other than the rods are cool? And I was like, well, it'd be nice to have a good synapomorphy brick stamp Proctotrupomorpha. So let me go through these characters and see, are any of them good? And the answer is maybe. No.
They're all bad.
They're pretty good.
problem is everything Rasmussen does, there's like zero evidence of, and then someone else tests it and he's usually right.
No, it's really annoying.
It's the most obnoxious thing he could do.
He just is like, I feel this, and then
Yeah, and it's
destines it to
usually
be
right.
so.
It's like someone does a math problem and they did all the work wrong, but then the answer's right. Damn it.
Yeah, again, he got there from this.
Yeah.
But I mean, in one of his recent papers, he's just like, all of phylogenetics is the same because no study reproduces exactly the same topology. And I'm like, there are qualitative differences in these studies. It's good for him. He's a man who knows what he likes.
Thank you.
Thanks, Sean.
Any last notes of anyone? Do I hear a motion to adjourn?
So moved.
I'll make a motion to adjourn.
All those in favor say aye. No objections? Okay, get out of here.